Hey class, how are you doing? Welcome back to another episode of Distance Learning Math 1 1809 with Mr. Mason. So I hope you guys are doing well. Recently, we have been working with inequalities, greater than, less than. We started learning how to graph inequalities. So today, I'm going to introduce the concept of what's called a compound inequality. So a compound inequality is where you take one inequality and you take a second inequality and then you push them together and you make one big one. And sometimes when you graph, the graphs are going to go in toward each other. And sometimes when you graph, they're going to go out away from each other. So let's go ahead and get started. You should have the notes in front of you, the handout, and I'm going to pull up my PowerPoint. So give me one moment here. And all right, here we go. So compound inequalities, compound inequalities. All right, so our objective is to solve and graph compound inequalities involving the words and or the word or, and those are called conjunctions. Okay, so the word compound, like compound words, we started learning about compound words back in about first grade. And we started learning about conjunctions, hopefully around first or second grade. So those two concepts that we learned all the way back in first or second grade are going to be impactful in today's lesson. So here we go. We'll do a little review. Okay, so a compound word, we started learning these in first grade. These are two small words joined together to form a big word. So back when you first started to read, two small words joined together to form a big word. Here are some examples, and they're on your notes already. So the word watermelon, that's really two small words, water and melon, and we push them together and we make one word. Snowman, snow and man, sailboat, basketball. See if you can think of a couple others. If we were in class, I would take examples from you. So what do you think? What's that thing called that's out in front of your house or your apartment? It runs along the street and you walk on it. A sidewalk. Ice cream, right? There's all kinds. And then you go through the football, baseball. Okay, so those are compound words. But what I want you to remember from that is that a compound is when you take two small things and then you join them together. Okay, now conjunction. Conjunctions are parts of speech, and we are specifically going to be focusing on the conjunctions and or. They join two statements together. You may have seen the Schoolhouse Rock called Conjunction Junction, what's your function? Right, it's a little train tracks. And so you've got the words and, but, or. We're going to be looking at the words and or. So for example, a conjunction, the word and joins two ideas together. So I might say to you, you are watching this lesson right now and you are eating lunch. So I took two ideas, watching the lesson and eating lunch, and I put those together. Or I might say, your options for breakfast this morning were cereal or Pop-Tarts, right? So again, I'm taking two ideas and I'm putting them together. So we're going to use the idea of a compound where we're joining things together, and those are going to be joined together by the words and or, and we're going to make compound inequalities. So a compound inequality is when we take two inequality statements, so a greater than, a less than or a greater than, or less than or equal to, or a greater than or equal to, when we take two statements and we join them together. So we take one here and we take another one and we join them together, and we do that with using the word and or the word or. So here's an example. We're going to take this small one here, we don't have to solve anything. So we're saying we want all numbers, x, we want all numbers that are greater than or equal to -3. Now, we've started practicing graphing these. So let's just review that here. So if I'm graphing this, I taught you to treat, remember I said treat the symbol like it's a direction arrow, as long as your variable is over here on the left side, which it is. So we want all values greater than or equal to -3. We have an equal sign. So we want the solid circle or the shaded circle, shaded. And then our street sign tells us to go to the right. So I want to draw that to the right. Okay, and then we have the word and. So that means we're going to take this inequality and we're going to join it with this first one. So on this one, this is, excuse me, no equal sign. And we're going to go to the number 6. We're going to have an open circle. And then this street sign tells us we want all numbers less, which means, excuse me, let me get a drink of water. We want all numbers less than 6. Our street sign tells us to go to the left, so I'm going to draw that to the left. Now, what this is telling us is we want all the numbers in between -3 and between +6. We want this set of numbers. So anything in there is a correct answer for x. But these are like stop signs. So even though we drew the arrow going to the right, as soon as we got to this circle, it's like a stop sign. We had to stop. And when we drew the arrow going to the left, this was a stop sign. So we want everything in between, okay? All right, let's try another one. Okay, so on this one, we got a little word problem. You don't have to freak out. It's not too complicated. So on this one, it says, write a compound inequality that describes all the real numbers greater than -2 and less than 5. Okay, so keyword, all the real numbers. So that means we're using a variable, x. And we want, so there's our variable. And we want x to be greater than -2. Greater than -2. And, okay, so keyword and we want x to be less than 5. So x is less than 5. So we're going to take this small inequality and we're going to join it with this one. Okay, so let's go ahead and graph these. So I want to start at -2. So I'm going to come down here, no equal sign. So we want an open circle. My street sign, my symbol says go to the right. So I'm going to start drawing that to the right. And then I'm going to go over here to this next one. And again, no equal sign. So I want an open circle. There's my stop sign. And this one says draw your graph to the left. And there's our answer. Okay, so we want everything in between those two numbers. So we want, oh, and this is another way to write this. I'll explain this in just a moment. But we want everything in between -2 and +5. Everything in between there, okay? Now, because we want everything that's in the middle, in between, we're going to put, another way to write this is just to put the x in between the two numbers. So we put the x in between. Now, notice that the symbols are both facing to the left. Well, remember, if we took this half right here, remember the Roadrunner trying to trick you, and we'd have to flip that around anyways. So really, it would be going this way, and this one would be going this way. And so they would be going in. Now, a way to remember this, an and problem, what letter is that? That's an N, and it's in the middle. It's in the middle. So if it's an and problem, your variable is going to be in the middle. It's an in between. Your graph goes in, okay? The graphs go in. All right, so we want everything between -2 and 5. And That would be all of those numbers. Okay, so your graph goes in. We don't want anything on the outside. Outside is no good. Okay, so we want the graph, everything inside the graph. All right, so that's an and problem. So those are two and problems. All right, now let's try let's try an or problem. So an or problem, we have this or this. Remember I said a moment ago, for breakfast you could have cereal or you could have Pop-Tarts, right? So it's one or the other. Okay, so let's go ahead and solve this one here. Just real simple. One step, we're going to subtract 1. We get x is less than 1. Okay, so we'll graph that in just a moment. And then over here, let's go ahead and solve this. We're going to subtract 5, and we get x is greater than 3. And this is an or problem. Okay, so now when I go to, so there's our answer, our solution. Now let's go graph it. So on the first inequality, it says we want all numbers, our variables where we want it to be, all numbers less than 1. So I'm going to go over here to 1. I'm going to do an open circle, and then that graph says go to the left, right? It's pointing to the left. So let's draw that to the left. Okay, now I'm going to go over to this one. Again, no equal sign, so we want an open circle. We're going to go to the number 3. So let's go to the number 3. And then this symbol, this street sign tells us go to the right. So we're going to go to the right. And there's your graph right there. Okay, so you can see down below, I was trying to give you a little subliminal message that the graphs were going to go out. They were going to go away from each other, out. Okay, so if it's an or problem, they're going to go out. The graph goes out. Okay, so that's a way to remember. If you see an or problem, then your graph has to automatically go out. It's either that way or that way. Okay, all right. Okay, an or problem. All right, now let's try this example here. So a little bit more sophisticated. And so in this example, I'm giving you a message already. You can see I've got the arrows going in. I'm trying to let you know this is going to be an in graph. Now, the way that we know this is because we can see that this variable is in between. It's in the middle. So if it's in the middle, we got this number here and we got this number here, and this is in the middle, then we automatically know our graph is going to go in. Now we just have to figure out where are those boundary, where are those stop signs. So what I'm going to do is I'm going to solve this all at the same time. So this might be a little differently than you've seen before. So there's my variable, and I want to isolate my variable, so I need to get this out of here. So what I'm going to do is I'm going to add 4, but I have to add 4 over here, and I have to add 4 over here. Okay, let me show you that again. I want to isolate my variable, so I'm going to add 4. So if I add 4, I have to do it on this side of this inequality, and I have to do it on this side, because it's really 2 inequalities. We're doing two problems at the same time. So I'm going to add 4. So those cancel. -6 plus 4 is -2. And over here, 4 minus 1 is 3. Now, I have already told you this is in the middle. So your graph is going to go in. It will always go in. The graph will always go in if this is in the middle. So now what I need to do is I just need to go over here to -2. So let's graph it. I'm going to go to -2 right here. This has got the equal sign, so I'm going to go shaded. Okay, and then this guy over here is no equal sign. So I'm going to go open. And now I've already told you they're going to go in together. I know that both of these symbols are both pointing to the left, but this is in the middle. So he's going to go that way, and he's going to go that way, and we want all answers. So X can be anything that's -2 or bigger, but then this is a stop sign, and then we need everything that's smaller than 3. So our answer can only be what's in the middle right there, in the middle. Okay, so, and then on your notes there, it's an in-between graph. We want all the answers in between. goes in. Okay, which would be, this would be an and problem. If we were to write it with the conjunction, it would be an and problem. All right, let's try a few more. And then the reason I put the Roadrunner on here is I just remember just this part over here. Remember, if we were just looking at this, we know that, well, that's on the wrong side. So we have to flip that around anyways. And that's why this is going to go that way. So that's really that. And that's where we get the going in. Okay. And that one is going to go, this one here goes that way. So they go in toward each other. All right, a few more examples. Okay, so once again, think to yourself, is this going to be an in graph or is it going to be an out graph? Look where the variable is. The variable is in the middle. It's in between, so it's going to be an in graph. Okay, now we're just going to solve this like we normally would. So we're going to, here's our variable right there. We want to isolate our variable, so we're going to subtract 4. But I'm going to subtract 4 here, and over here. You've got to do it in all 3 spots, all 3 places. So this is going to give me -9, and 7 minus 4 is going to give us 3. Okay, and then what we need to do next? That's right, we want to divide by 3. So these cancel. -9 divided by 3 is -3. Here's my x, and then 3 divided by 3 is 1. We already have established that this is going to be an in graph. So we just go to this boundary. We're going to go to -3. And this is going to be an open circle right here. And then over here, we're going to go to +1, and that's going to be a shaded circle. And we're going to go back the other way. And those are going to go in toward each other. So our solutions are anything in between these. It cannot include -3, but it could include +1. That's why we're shading it right there. Okay. All right. A few more examples. This is an in-between graph. It's going to go in, right? The variable is in between the two. Okay, once again, think about where that variable is. Where is that variable? It's in the middle. So this is going to be an in graph, in graph right there, in graph. Okay, all right, there it is. Okay, so the first thing we're going to do is subtract 6. These are going to get canceled. This is going to give me -10, and 8 minus 6 is going to give me +2. Now we have a problem. We've got a negative variable. We cannot have a negative variable, right? We can't leave this with a negative variable. So to get rid of that, I'm going to divide everything by -1. But when I divide by -1, that's going to change this. This was a -10. It's going to change it to a positive, which means I have to reverse my symbol. And over here, this was a +2, but now it's going to be negative. So I have to reverse that symbol. Okay, so when I reverse those symbols, now, where is the variable? It's still in between. So even though these are both pointing the other direction, this is still in between. So we know it's going to be in between. Okay, so we're going to go to +10. Over here, and that's got the equal sign. So we want a stop sign that's shaded. And over here, this is -2. We want no equal sign, so that's going to be open. We're going to go that way, and this one is going to go that way. They're going to go in toward each other, because it's in the middle. It's an in-betweener. Okay, in-betweener. Okay, here we go. Last one. Word problem. A racquetball club charges a $20 membership and $2 per hour. How many hours per month can Joe play on a budget of $50 to $70? Okay, so here's Joe. I don't know if you guys have ever played racquetball. They have them sometimes at 24-hour fitness, sometimes at LA Fitness. It's kind of like handball, right? I think many of you probably have seen handball or know how to play handball. But you play with this little tiny racket, looks like a tennis racket, but it's smaller. And you play in where you've got like walls all around you, and then one wall is all glass so people can watch. And it's a game like handball. Okay. So, so Joe, he has a membership, and his club charges $20 membership. So that's an upfront cost, and then $2 per hour. But he sets aside, he has a budget of $50 to $70. So we want to figure out, well, how many hours a month could he play? Okay. So to do this, we're trying to figure out how many hours. Okay. So we're going to let X equal the number of hours because we don't know how many hours. Okay. We're trying to figure that out. We don't know. Okay. And then we're going to write an equation here, and we want to let C, the variable C, equal the total cost to play racquetball. Okay, so this is the number of hours, and this is the total cost. So that means we're going to so C is going to be the $20 membership, right? That's our upfront amount. So the total cost is going to be $20 plus $2 per hour. So $2 per hour. And X is our number of hours. We don't know how many hours he can play. Okay. All right. So to do this, we're going to set up a chart. There's a faster way to do it, but we're going to just set up a chart. So now let's say that Joe, he goes down to the racquetball club, and he signs up. He pays his $20 membership, and then he walks outside and he steps off the curb and he breaks his ankle. So he's actually not going to be able to play racquetball. Do you think if he goes back in and he asks for his money back, they're going to give him his money back? Maybe, but probably not, especially if he breaks his ankle a day later. They don't really care. They got his $20 membership. Okay, so if he winds up not being able to play any hours, so 0 hours. So if I was to put a 0 right there, 2 times 0 is 0. So it's still going to cost him $20, right? But let's say he finds out that his ankle actually is not broken. It was just badly sprained. And so he takes care of it. He ices it and elevates it. And then he's back playing racquetball. So remember, we're trying to figure out how many hours he can play. And down here is what the cost is. Okay, so let's say, what's the cost for 5 hours of racquetball? So I would take the 5, go over here, plug it in, 2 times 5. 2 times 5 is 10 plus 20. So that would cost him $30. Okay. How about $10? Or I'm sorry, 10 hours. 10 hours. If I go 10 hours, 2 times 10, that's 20 plus 20 is 40. You guys starting to see a pattern here? So if I go up 5 here, I'm going up 10 in cost. If I go up 5, I'm going up 10 in cost. So let's see, what would 15 be? If I go up 5, I'm going to go up 10 in cost, so it'd be 50, right? If I plugged in the 15 right here, 2 times 15 is 30 plus 20 is 50. Okay, how about 20 hours? How much am I going to jump by? That's going to go up to 60. If I go 25 hours, this will go to 70. How about 30 hours? Let's say his ankle's feeling really good. He's playing a lot of racquetball. So 30 hours, that would cost $80. Okay. Now, let's go back to the question here. I don't want to lose you here, so hang in there with me. So it says, how many hours per month can Joe play on a budget of $50 to $70? So some months he's going to have $50, and then some months he'll have as much as $70 to spend on racquetball, right? He's got to buy groceries and he's got to buy other stuff. And so sometimes he has $50 and sometimes up to $70. So where is that down here, right? So let's find that. Well, here's 50 and there's 70, right? So there is That's the space, right? The space that he has. So how many hours is that? How many hours? That's between 15 and 25 hours. So if I was going to write an inequality for that, it's between 15 and 25. So what would that look like? This is an in between, right? So we want everything in between. We want everything in between those numbers. So it would look like this. It would be X is in between 15 to 25. So anything in between, right? It's an in between. Okay. So Joe can play anywhere between 15 and 25 hours. Between 15 and 25 hours. Okay, on your notes, I think there's a little section just to write yourself one tip. So we covered a word problem here, but we also covered some and problems and we covered some or problems. Okay, and then what's a tip to help you remember? Okay, so think through what did I say? What does an and graph look like? What does an or graph look like? So you can come up with a couple of tips for yourself. Okay. All right, so go ahead and you don't have a neighbor to discuss this with, but if we were in a class, you would turn and talk with your neighbor. Okay, let me stop sharing this. All right, so you're gonna have to go back maybe and pause, rewind, watch the video again, look at the slides, because you really gotta know this for your next test. Okay, so compound, we're taking one little one and we're taking a little one here, and we push them together with the words and or, and then sometimes we just put that X right in the middle. If it's in the middle, we're going in. Okay, all right, that's all I've got for you. Go ahead and complete that, and I will see you in our next video lesson. I'll see you guys. Bye.